in enthalpy when 1 mole of a substance is converted from liquid to gaseous state at its boiling point. You know what we call vaporization. All these things are what you have already in your note: vaporization, neutralization, and so on. So vaporization here, we are talking of the heat involved when you convert a solid to liquid. That is, during melting point you have fusion, but when you talk of vaporization, then you should know that that liquid is now changing to gas. Remember, heat of fusion, heat of vaporization, one is leading to the other, and I'm trying to bridge the two. You have heat of fusion where solid is changing to liquid. Then you have heat of vaporization when the liquid is now changing to gas. Then here we also have heat of sublimation. It is a change in enthalpy when 1 mole of a substance is converted directly from solid to vapor. It's under matter in SS1. We told you that we have some solid that can change directly to gas, that is the sublime. So the heat enthalpy change or heat involved during that process is called heat of sublimation. Then we also have heat change and chemical bond. I told you before now that before any reaction can occur, the bond must be broken, which means that all compounds are being held together by a bond. Now the type of bond involved will now determine how strong it will be, or how difficult it will be to break those bonds. Now here we say the energy needed to break bond is called dissociation energy. I told you before the reaction can occur, the bond must be broken. So what are you doing? You are dissociating them, and then that means you are breaking the bond holding them together. So we refer to that energy required to break those bonds. The energy is called dissociation energy. So look at this place. In a reaction, if the energy needed to break a bond is less than the energy produced by the bonds formed, then the reaction will give off energy. It's still like when the heat of reaction is higher than the heat of product. We have exothermic. So the same thing is applicable here. Bond will be broken in reactant side, while bond will be formed in the product side. So when you are breaking the bond in the reactant side, what you are doing is dissociation. So if the energy you use during that process is higher, is higher than the energy you obtain when the product is being formed, then what you will be having there is exothermic. But if the energy is lower, the dissociation energy, if it is lower than the bond being formed, then what you have there will be endothermic. So take note of that. So we said the bond formation energy is the amount of energy released when a covalent bond is formed. We have bond dissociation and we have bond formation. So dissociation will occur at the reactant side, while formation will occur at the product side. So bond dissociation, reactant; bond formation, product. So take note of that. So the weakest bonds have the smallest value. The smaller the bond energy, the more reactive and weaker the bond. You know why it will be reactive? Because the bond will be easily broken. So before you know it, reaction will occur. Without breaking of bond, there will be no reaction. So once bonds are being broken, then the next thing is they will now react. So if the bond holding them together is a weak bond, then definitely it will be broken easily and then it will be reactive. So compounds that are being held together by a weak bond tends to be very reactive compared to those that are being held together by a strong covalent bond. Then from there we go to what we call thermodynamics. Now, thermodynamics is defined as the branch of science that deals with the relationship between heat and other forms of energy, such as work. In other words, thermodynamics is a branch of science which deals with the study of the flow of heat or any other form of energy into or out of a system as it undergoes a physical or chemical change. That is the measure of heat flow when you are converting it from one state or one form to another. So the study of the measure of such heat flow is called thermodynamics. Now this thermodynamics can be summarized into 3 laws as stated here. Now we have the laws of thermodynamics. We have the first law: energy is conserved. That is, energy can neither be created nor be destroyed, but can be transformed or transferred from one stage to another. Then we also have the second law, which says in an isolated system. Remember we call isolated system when we are looking at the various type of system. We say in an isolated system, there will be no exchange of any form between the system and its surroundings, no exchange of mass, no exchange of heat. So the second law here is about an isolated system. We say in an isolated system, natural processes are spontaneous when they lead to an increase in disorder or entropy. We are still going to look at entropy, so you'll be able to understand this better. Now, the third law: the entropy of a perfect crystal is 0 when the temperature of the crystal is equal to absolute 0.